Hello, my name is Sebastián Navarro, and today, along my classmates Andres Chavez, Fabián Guzmán, and Fernando Rivera, we will be reviewing the Journey file systems, more specifically, the ext file systems. First things first, what are Journey file systems? They are high performance journaling file systems introduced in the Linux world. Developed by IBM, they prioritize reliability and scalability, making it suitable for enterprise level applications. Its journaling capabilities ensured fast recovery from system failures, enhancing data integrity and system uptime. Talking about EXT, before it was born, there was Minix, a foundational operating system developed by Andrew Tannenbaum. Minix's microkernel architecture, where device drivers run as isolated user mode processes, enhances security and reliability. Though commonly known as a footnote in the history of Linux, Minix's influence was undeniable. Now let's talk about the first EXT, which means extended file system. It was released with the Linux operating system in 1992 to overcome the size limitations of the Minix file system. They made structural modifications concerning the file system metadata, which was based on the Unix file system. There is little information about this file system because it had major problems and was quickly replaced by the ext2 file system. And speaking about the ext2, it was easier if you consider the amount of disk space left between the metadata structures of its next use. Like Minix, ext2 contained a boot sector in the first part of the hard disk on which it is installed, which has a minimal boot record and a partition table. About ext3, its unique addition to the ext file system was the journaling feature, which locks in advanced changes that would be made to the file system. The journaling feature decreases the time required to check the hard disk for inconsistencies after a failure from days to only a few minutes at most. And finally, in the ext4 file system, a significant improvement in the mapping of data from fixed blocks to extents was implemented. Instead of mapping individual blocks, we now describe proximate extents on the hard disk that contain large and physically adjacent file data, which reduces fragmentation.
Hi, my name is Fernanda, and I'm going to talk about some of the key features of the X4 file systems. I'll be covering the first four features, so let's dive right in. Let's start with the first feature, file system size. X4 supports larger file systems and individual file sizes compared to the X3. X4 can handle file systems of up to 1 exabyte in size and individual files of up to 16 terabytes. Moving on, we have the extent allocation, which optimizes file management by using continuous physical blocks, reducing fragmentation and enhancing performance. Next, we have the delayed allocation and multi-block allocation. Delayed allocation defers block allocation until needed, while multi-block allocation assigns multiple blocks in one operation, boosting efficiency. Okay, so now I'm going to talk about the remaining features. So now we have the journal checksum, which ensures data integrity by verifying journal block health, mitigating data corruption risk. Next, we have the iNotes or timestamps that offers enhanced flexibility and accuracy with larger default iNote sizes and nanosecond level timestamp precision. Lastly, we have the backward compatibility that allows seamless migration from X3 to the X4 without formatting or reinstalling the OS. So basically, all of these features collectively make an X4 a robust and adaptable file system meeting the modern computing demands efficiently.
Now let's talk about advantages and disadvantages. First, we have the flexibility and customization in mounting. This means that you can enhance protection, influence performance, and stability in detail, tailoring to the specific needs of each application or environment. Next, we have control over fragmentation and maintenance. This means that a specific partition are independent of the others, enabling you to efficiently optimize and maintain each file system without affecting others. Next, we have advanced management and security. This means that you can perform a variety of advanced actions such as creating snapshots, encrypting specific volumes, mounting volumes on demand, and enhancing security and operational efficiency. Next, with the disadvantage, we have the increased administrative burden. This means that by using different volumes increases the administrative burden by requiring grading, tracking, and management of multiple files, which can result in additional complexity and more time spent on system administration. Next, we have this disk space waste. This means that by distributing data across multiple volumes, there is a little possibility of wasting more disk space than necessary due to less efficient storage resource and management. And finally, we have the difficulty of creating consistent snapshots. This because creating consistent snapshots of applications running on different volumes can be more challenging due to the added complexity of managing multiple file systems, and this can cause and this can compromise the data integrity.
Now, the ext4 file system has emerged as the difficult choice for many popular Linux distributions like Ubuntu and Debian. However, it's officially incompatible with Windows and macOS. Despite these limitations, there are solutions available to overcome this. For example, Windows users can employ third-party applications to access this type of file systems. These applications provide seamless integration and ease of use. Another option is to use Windows Subsystem for Linux, a compatibility layer for running Linux binaries natively on Windows 10. On the other hand, users can convert this type of file system to NTFS, the native file system for Windows. This allows for direct compatibility with Windows operating systems. And on the other hand, macOS users can leverage MacFuse. This is an open source framework to enable access to ext4 file system. These solutions provide a user-friendly interface and robust performance. Hosting ext4 file system with a virtual machine is another viable option for macOS users. Platforms like VirtualBox and VMware Fusion offer seamless integration and efficient resource utilization. Similar to Windows, macOS users can explore third-party applications designed to bridge the compatibility gap between macOS and ext4 file systems. Well, as a conclusion, the history of Linux file system from ext to ext4 reflects a continuous effort to overcome limitations and improve performance. ext4 emerges as a robust and feature-rich file system, offering benefits such as increased file system size, improved performance, and backward comparability. And finally, while ext4 excels within the Linux ecosystems, its comparability with Windows and macOS presents challenges. However, users have devised solutions such as third-party applications and virtualization technologies to enable cross-platform usage.